gotta look our best. You look great though, it's good. Hello, and welcome. They let us in. I'm in the classroom with Skelly for the first time. He's wearing his Christmas holiday jumper, thinks he's got to Hawaii. It's fine. We're here. Welcome to our space, because it's our space now, because we were let in. And I'm excited, not only because it's Christmas, but because we have an idea. We're going to be talking about how Santa flies, because I think I have an idea, because I'm excited about coming up with solutions, because that's what scientists do. We are always on the hunt for solutions, ideas, and we are going to go through some experiments where I think I have an idea of how Santa flies, because I believe Santa is a scientist, and some people think it's just magic, but I believe that magic is just science that you haven't figured out yet. And I know I have a giant plate here. It is about the same size as my Christmas dinner plate, but it's a ring of magnets. We will come back to that later on, and I will explain it because it is part of my experiment. But I am talking to you about how things behave in cold. And if you even think of what it's like yourself when you're at home, when things are cold outside or you're cold, you kind of sometimes just want to stay inside and not move. Or if things are really hot and you want to summer and you want to go out to the beach and you run around. Materials behave a lot in that kind of way. Generally things will contract, kind of sit and not want to move much if they're cold, and if they're hot and they've lots of energy, they want to fly all over the place. Some other materials behave a little bit differently, but we're going to have a look at both of these using stuff that's really cool. And by really cool, I mean cold. Like this, think of the ice that's in your fridge. That's pretty cold. That's about -4 degrees Celsius. This stuff is liquid nitrogen. It is very cool in that it is -196 degrees Celsius. So a little bit colder than ice. So as I open this up here, you can see when I blow into it, it instantly evaporates and turns into a gas. So this stuff is very, very, very cool. And this balloon has air inside it. So the same air that we breathe, which actually has nitrogen. So this is the liquid form of it. There's 70% nitrogen in our air. We breathe it. It's inert. It doesn't have any danger to us. But this stuff is really, really cold. So when I put this in here, what it's doing is it's cooling down the balloon, like the latex, the rubber that's on the outside, but it's also cooling down the gas that's inside it, which means that as it cools down, I can kind of keep pushing it down inside it because it's shrinking. Like I said, remember when you're cold and you don't want to go outside anywhere? It shrinks in and shrinks in and shrinks in. And when I take it out now, I hold it up like this, I put it down like that, it'll expand back out again. So because the air inside, the air around us, the temperature is bringing it back up to the same temperature. So I'm going to try and hold on to this with my things here. Okay, so I'm going to put this in here. So I'm going to cool it down. I'm going to cool it down a little bit more and push it in. But the same thing is happening. Imagine you're going outside or you're cooling down something. This is something that you can try yourself at home, not with liquid nitrogen, but you could try putting a balloon in the fridge. See what happens when you take a balloon, see what size it is, put it into your fridge, and then see what happens to it a few hours later. I'm cooling this down, I'm cooling this down, I'm cooling this down, and now, look at that. I'm going to watch you take this for magic. I have magic breath, cool breath, because it's expanding out, because my breath is warm. It's even, you see it, I kind of, coldness, snazziness. There you go, look, whee. Okay, go on. Nailed it. So, things behave that way when they're cooled down. Now, another thing, which I have around here somewhere, is this. Yeah, no, I'll use this one. Because Skelly has a nice little rose over there, looking great. So I'm going to put this inside. This is a rose. It's nice and soft. It's malleable. It's beautiful. It smells a bit, okay. But anyway, if I put this in, now normally previously what we had with the balloon, it cooled down and it shrunk. Do you think the same thing is going to happen with the rose? Listen to it. That's actually the liquid nitrogen boiling, because the rose is so hot in comparison that it takes a little bit of time for the things to cool down. Now, what's going to happen with this, and I'm going to put a glove on for this, is now, it hasn't shrunk. Now it looks, if I blow on it, it still has that smoking. But what happens when I press it now? You'll see that it's frozen. So things behave differently depending on what temperature it does to them. And usually they contract, but sometimes things behave a little bit differently. Like the next thing, and this is the idea that I have how Santa, ignore that, how Santa flies, because this, like, is, I said, a ring of magnets. And inside this, I have what's called a superconductor. And a superconductor is really great at conducting. It's a superconductor, and that means it allows electricity to fly through it really, really well. But if you cool it down, and I take my tongs again, and I put it on top of my ring of I drop it. Hold on. I put it. Oh, turn it up that way. There we go. Yes, works. On top of my ring of magnets, it floats. And this is how I think Santa flies around the world. He uses the electromagnetic field of our Earth, our planet, and like these are magnet, he cools everything down because it's winter and it's cold. And then he flies around using a sled made of superconductors. Santa is a scientist. He is going to be fine to fly around. Is Santa able to fly upside down? The answer is maybe. I'm just going to flick this on. I have protective gloves. Stay. Yes, it does. Oh, snazzy. I told you it was worth having me in here. Look, I know I look like Arthur Christmas. I don't care. I'm happy. I'm inside. Santa's the scientist. He does it better than me, but I don't mind. Happy days.